reinstalled my Zoom, so we'll see if it.
Yeah, we missed you last week. There's a lot of
I kept dropping out. So
QSB on your end, right?
Yes.
Yeah.
Your QSB.
So welcome to the March 2nd, 2021 session of TangerineSDR and HamSCI technical personal space weather station technical talk. So I'm Dave, KV0S, and this week I've been working on the programming simulator, and I've at least got both ends talking as simulation, so at least in protocol 1. And I have some questions for Bill and Tom a little later, but things are moving forward, so that sounds good. And that's about it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. It's been a very busy week for me. I've been working on getting the HamSCI workshop moving along. I've emailed almost everyone who will be presenting at the workshop, so they know that. I am working on getting the iPosters set up. The contract is in place, so I'm going to email them the contact information for the people who've responded back to me tonight. So hopefully by tomorrow, people can start building up their iPosters. I've got the registration link is up on the website. So if you go to hamsci.org and you go to the workshop page, you can now register to participate in the HamSCI workshop. Note that if you are presenting, you don't need to register because I will send you a special panelist link that you will be able to participate as a panelist if you are one of the presenters. Let's see, the other big thing is we had Jay Silber from he is the PIO for the Eastern PA section of the ARRL. He did a special on the Grape personal space weather station that premiered on YouTube last night. And so there's a link in the chat about that. And so I'm in the video, Frankie Bonte's in the video, John Gibbons is in the video. This is a very nice video. And then finally, Bill Engelke, Phil Erickson, and I have been working on a NASA proposal to look at traveling ionospheric disturbances in RBN, WSPR, and PSK reporter data, and we got it submitted today. So it's been a big... So that's all.
Very good. Well, next on the list, we have Dan in for XWE. Go ahead, Dan.
Okay. Can you hear me okay?
Yes.
Okay, perfect. I got the difficulties with my script for the new radio sorted out. And thanks to some comments by Tom McDermott, I started thinking in the right direction. And after I started thinking in the right direction, everything fell into place and it works very well. So learned a lot last week and looking forward to next week. And I see Bob McGwier just showed up. My heavens. Hi, Bob. Okay, back to you, Dave.
Well, fine business. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to you and good evening to the net. As Nathaniel mentioned, we worked with him a little bit on getting the NASA proposal put together. Also, I've been working a little bit on getting a Pi hat with a GPS chip on it, working on the Grape so that it could know the time of day and know its location and some things like that. And in working on that, I managed to mess up the rest of my system to where the new radio wouldn't even work. Okay, I mean, I've got it to where I can show the serial input and the data coming from the GPS chip card. The Pi hat is just fine, and I've got software that can parse it and convert it to a Unix time, which you need for digital RF. But then somehow I managed to trash GNU radio, so that I used Dan's script. I should say, Dan, the new script worked fine, but it still didn't solve my problem. It ran through without any problems, but when I try and run GNU radio, it starts, well, it seems like it's starting, and it consumes 1% of CPU time, but the user interface never shows up, and you see it there, and there's a process running that's taking a little bit of CPU time here and there. So I'm thinking, oh man, what did I screw up? So I'm starting thinking to myself, do I have to rebuild the whole system to get back? Anyway, so we're making some progress. So we will have something, once we get past that, we will have something for the Antarctica project, barring any real unforeseen circumstances, where it'll be able to know where it's at, assuming you can get a GPS fix. The first Pi Hat they sent me, the antenna connector fell off. It wasn't even there. And so I had to get a replacement, Anyway, so making some progress, but you know, like these projects always are, very slow and difficult. So anyway, back to Ned.
Well, fine business, Bill. And I know those weeks happen. So anyway, next on the list, we have Bob in for HY. Welcome, Bob. Bob would like a comment.
Yeah, sorry, Ed, the net froze. So I'm interested in TangerineSDR because I'm trying to build an ionosonde out at Kentland Farms, which Nathaniel knows well. And we now have access to high-speed connectivity out to Kentland Farms, so we can build quite the instrument out there. And as Nathaniel knows, and maybe many of the rest of you know, Virginia Tech has quite the group of ionospheric research scientists, and I'm looking at TangerineSDR as a potential component for that. I have read Pitaya. I'd rather use TangerineSDR. So just for everyone's information, I'm now on the board of ARDC, and ARDC is very, very proud to be supportive of the TangerineSDR, and we're looking forward to all it can do and see how it grows and all the things that it will enable going forward. And I'm very happy to be here. I will be here more often now.
Go Hokies!
So
nice to see you, Bob.
Thank you, Bob. I appreciate that. And welcome to the list. So next on the list, we have Dave, KDE0EAG. Go ahead, Dave.
Hello. Nothing to report. Nothing I want to report at this time. So back over to you.
Fine business. And next on the list, we have David, N1HAC. Go ahead, David.
Good evening, everyone. I continue to work with VLF stuff and preparations for our Viper sounding rocket, which is a VLF propagation mission flying from Wallops. We're currently scheduled for the middle of May. We'll see if it happens. Back to Net.
Fine business. And then next on the list, we have Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just copying all the traffic and trying to stay current. Back to Net.
Fine business. Next on the list, we have Homan, KD2MCR. Go ahead, Homan.
Good evening, everyone. Yeah, I've been nothing really specific to report other than I've been working on some science aspect of the magnetometer applications. I'm trying to work with my colleagues who is calculating the level of currents around the Earth using the array of magnetometers, and trying to prepare for abstract and title for HamSCI workshop as requested by Nathaniel. So other than that, yep, that's all I have to say. Back to Nat.
So I have a question for you, Nathaniel or Holman, have either of you heard from Jen about the access to their magnetometers?
I haven't heard.
Okay, I haven't either. So I just wanted to make sure we're on the same page.
You mean Jennifer, right?
Yeah, Jennifer.
Gannon?
Daniel, yep.
She nominally allowed Dave and I to use the one here in Columbia. There is a magnetometer that she can, is it DAST? Her project, NSF project,
Daisy
has
project?
one here. Huh?
Her Daisy project?
Yeah.
Yeah.
So she offered that, but they haven't told us when the site was available. They said sometime mid-February.
Yeah, I haven't seen anything come across my email.
Okay.
So I'm supposedly on a list, but I haven't followed up on it. And I can't say I was, really closely looking for it, but I don't remember it coming across my email.
Okay. Just wanted to make sure I didn't miss something there.
Yeah,
anyway.
Speaking of that, related to that, I was wondering if anyone's checked magnetometers today. We had a pretty good geomagnetic storm overnight.
Yes, my Whisper got a lot of good spots last night. So
I haven't plotted my data yet, but I will.
So next on the list is James, KG4DSG. Go ahead, James.
Yeah, I'm here just listening in, checking what's going on, and turn it back to the net, KG4DSG.
Oh, okay. Next on the list, we have Jim, 7J1AJH. Go ahead, Jim.
Good morning. Just listening. Thanks.
Okay. And then next on the list is another Jim, K4BSE. Go ahead, Jim Farmer.
I think I needed to unmute myself. Sorry. I had gotten a little bit concerned listening to the conversations about logging WWV at the South Pole. And so I had gotten kind of curious about what stations might be on the same frequency. So I made myself a spreadsheet that I've spent a little bit of time on of all the stations I could find worldwide that were on. Well, I went from 2.5 to 25 megahertz to see how many stations might be QRMing those WWV frequencies. There are a lot of stations on 5, 10, and 15 around the world. I've sent that spreadsheet to Christina. I don't know whether she's done anything with it or not. I think she had some people looking at that issue too. So I don't know anything about that. But there are a lot of stations to try to listen through for WWV. I've downloaded VoiCap now, and I'm going to see if I can play with that a little bit and see if I can get some propagation guesstimates off of that. But it's going to be interesting.
Very good. And next on the list is Joe, W7LUX. Go ahead, Joe.
Yeah, thank you, Dave. Again, good evening, everybody. I've been spending a fair amount of the week between a couple of projects. One, we've got mountaintop repeaters that need work. And the other one is trying to learn more about this HamSCI project, including the Tangerine. And right now I've got a 10 meg oscillator feeding a spectrum analyzer, trying to figure out how far down I can see, and not very far. Anyway, that's what I've been up to. So appreciate hearing what everyone else is doing. Thank you.
Well, fine business. And next on the list is John, N8OBJ. Go ahead, John.
Good evening, everybody. Last week, I pretty much disappeared, had some personal family business to attend to, and I'm digging myself out of emails right now. I did see some activity concerning making the Grape 1 a kit. I haven't talked to anybody about that yet, but I took the impetus this afternoon. I created a parts list with all the Digikey part numbers included with it to build one and put the schematic, the board layout, and everything up on the PSWS documentation directory under the Grape Gen 1 stuff. So it's all up there if someone wants to do that. I guess the only thing I ask is they don't change the layout or anything on that, but we'll get into that later. Also, I've just had some correspondence with Pete and Gareth about installing the Grape 1 station at their place. I'm going to have a meeting with them tomorrow night to help them hook it up and get that working. So other than that, nothing else going on. Back to net.
Well, fine business. That sounds like you did a lot, even though you were sidetracked for a while. So next on the list is Jonathan, KC3EEY. Jonathan, is your new job working out?
Hi, everybody. Yeah, it's been pretty fun. It's kind of slow to start. I'm reading a lot of documentation, but I'm slowly learning about what I'll be working on and also about government work. It seems to be it's completely different than I've ever experienced. So that's really cool. I don't have anything to report other than I was wondering if well, this is a question for Scotty, if he was able to figure out what voltages are available for the master clock for the module, because I need 1.8 volts since he has 1.8 volt IOs, and I was wondering if you figure that out. Maybe that'll be for general or after discussion. That's all I have. Back to the net.
Well, fine business. And next on the list, we have Jules, K2KGJ. Go ahead, Jules.
Okay, thanks, Dave. A few things this week. Last week I missed due to some snow clearing operations here at the same time. Nathaniel had asked me if I had some recent information on Antarctic propagation from pole. I happen to have a couple of SJT FT8 logs that Pole Station recorded on a 24-hour run on 40 and 20 a couple of years ago during our summer, or late fall, or early fall rather, for a contact that we were planning out of K1TTT here nearby. And I forwarded those to Nathaniel, which has some interesting stuff including signal levels from various parts of the US and various parts of the world. The other thing this week that I worked on was testing or measuring timing actually on an I2C multiplexer that Dave Whitten and I have been looking at, and found that it's an 8-port I2C multiplexer. Each port would handle up to 4 magnetometers if we decided to do that, and found that it adds very, very little overhead at all, enables us to essentially scan at whatever speed we want. Other than that, back to net.
Fine business. Next on the list is Michael, AAAK. Go ahead, Michael.
Well, thank you. Greetings to everyone on the conference. Back to you, Dave.
Very good. And next we have KJ6MKI listed as monitor only. I don't know if they want to say anything or not. I guess not. So next on the list is Robinette. Go ahead, Rob.
Hi, hello everyone. I'm driving, so I'll keep it brief. But I just thought I'd listen and make sure I'm up to date. You know, I'm doing the same stuff. I'm doing major revision on my Whisper Daemon program. One of the primary goals is to start to add support for the new FSE4W whisper modes that were introduced in JTX 2.3. And among those, in addition to about almost 2 dB improvement in sensitivity, use of those modes, there's some longer packet lengths. They've introduced 15-minute, 30-minute long packets, which the effect of which is to increase the sensitivity by 10 or 12 dB or more over current whisper packets. Of course, you have to have a very stable signal. You can't have Doppler in those during those transmissions. So anyway, there aren't many people using it, but hopefully when all of my clients, or most of the top spotters, top 10 to 20 spotters are all running my software. So once we do that, hopefully we'll see these new whisper modes and maybe learn about propagation events that heretofore have been not observed. Just because, our sensitivity levels now will be significantly greater. We'll see how many people are actually using it, though, and I think there's a chicken and the egg thing with Whisper, 30-minute Whisper, Whisper 1800 seconds is, I guess, the term. But once we have listeners, hopefully there'll be more transmitters and, more whisper events, maybe we'll see propagation events that weren't previously observed. Anyway, that's my area of interest and activity right now. Back to Nat.
Very good. And next on the list, we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, very good. Thank you, Dave. And lots of progress made this week. Did a prep and a talk at West Central Florida TechCon on the Tangerine. So that was kind of fun. It was about a 50-minute talk and maybe help get the word out. They put the videos up on YouTube. So if you want to search for WCF TECHCON, West Central Florida TechCon, it's a section event that they have every year. And it was kind of patterned after the TAPR DCC, a little mini version of it. So did that. And I sent some boards off to Jules. I hope he got them. You have to kind of keep track of stuff like this because deliveries with the weather have been not so good. Lots of progress on the data engine. We actually have a clean read-in. The CAD guy has a clean read-in of all the PCB decals on the board. So we've got them all built, and since the last time through, I found 2 errors in the decals. I went through and checked every single one again, just to make sure I didn't lose anything. Didn't find any additional errors, but now I have better confidence that we're not going to have a problem with having a pin swapped or something. Also completed the Quartus project with all the pins listed and have gone into the Quartus tool and assigned the pins to the pins that I have on the schematic to verify that, in fact, it will let us build an FPGA that will have the same pin out as what I have on the board. Found some problems, so I had to spend today switching some data buses around to make sure that we had pins that had the right I/O voltages and the right I/O characteristics that we're allowed to set in the Quartus tool so that we can get an FPGA that's actually going to work. The next, incidentally, this project we're going to use for, Dave and I are going to use this for building the initial loader, the bootloader and the programmability, so you don't have to load all the Quartus software to do an update, because I envision there's going to be lots of updates here coming out as we get hardware, and it'll be very nice to not have to load a huge cumbersome program to be able to upgrade your software, your firmware in the FPGA. Didn't get to do it today. Was supposed to have a telecon with the CAD guy today, and I'm guessing by next week we're going to have a placement for the data engine, and we'll be able to check the fit of the RF module, which of course is completed already. And so that's going to be pretty exciting because I'll have something to actually show, concrete to actually show a board with where the parts are going to be. Jules, do we need to build you a little motherboard so you can put like 8 magnetometers on one board? You seem to be wanting lots of them. So
no, that's all right. I've got a double-sided PC board set up for that, and I also sent you a note on the chat that I did receive the parts today. Thank you.
Okay, great, thanks. I'm thinking of an octomagnetometer. Anyway.
Well, you know, a couple of people have been interested in the rays, Dave and Hellman, and we thought we'd at least test this multiplexer, which again really adds extremely small overhead to the switching time, and doesn't once you've switched ports, which it doesn't slow down the bus at all.
So I take it then you can actually take this multiplexer and hook 8 of the multiplexers that you already have up to it without having to redo anything, right? Is that right?
That's correct.
Oh, that's going to be awesome. Okay. Anyway, that's all I have, Dave. Back to you.
Well, fine business. And next on the list should be Tom, N5EG. Go ahead, Tom.
Oh, good evening, Dave. Hi to everybody on the group. A little bit of work. I also gave a presentation at the WCF TechCon, the very basics of GNU radio. It was interesting. The installer GNU radio got a forced undesired upgrade the day before due to repository renaming of GNU radio. So I managed to wind that back and got that fixed in time for the demo. And I've had a bunch of off-list Q&A with Dan and a few others on some other ideas. Back to the group.
Well, fine business. And I believe that is the list. Has anybody been missed? Well, if not, we're open for general discussion.
So Tom, how did you get many questions on GNU radio?
I've got a few. The Q&A probably lasted 6 or 7 minutes.
Sounds good. Sounds like there's some interest.
Yeah, I haven't looked at the video yet, so I guess they put one up.
All right.
Yeah, it shows a video of the whole thing and then individual talks as PDFs.
Okay.
So I had a couple things I wanted to ask about tonight. One, I wanted to know from Jules and Dave Witten and Hyomin. I talked about it a little bit on email, but I was wondering, I was thinking for the HamSCI workshop of splitting the magnetometer, talking to 2 parts, a science and a hardware part. And I think Hyomin's going to take care of the science part. I was wondering if, if either Jules or Dave wanted to lead the part on the hardware.
Sure. There's a software part to this as well.
Yeah.
But did you want to split that out as well?
Well, whatever you think is an appropriate update, because I guess, so what I'm looking for is an update from like what's happened since TAPR DCC. So okay, as far as I know, there's a lot of stuff that's been going on. There's been software developed. You've come up with that nice PVC pipe holder for these devices. I know you've also been doing a lot of testing. So I think all of those would be really good to hear about.
Okay, why don't I get together with Dave and we'll work that out.
Okay, that sounds really good. So tentatively, in a minute, I can tell you tentatively what time I have you down for doing that. It'll be on Friday, the 19th.
Okay.
It's going to be in the morning. It's around like 10:40 or something like that. I can give you the exact time in a couple minutes.
Good.
Thanks. And then the other thing I wanted to ask about was John Gibbons. Thank you very much for considering doing that kitting. The problem, it's a really good problem we have. So Christina Collins led the authoring of this really nice EOS article that went out to AGU through the American Geophysical Union about the Personal Space Weather Project and HamSCI in general. And so we've gotten a lot of really good press from that. And now this Eastern PA video just came out too. And so now I'm getting emails all the time. They're like, when can I get something? When can I get something? And I think we are still we have some Grape hardware that is, you know, out there, but there's no way that we can really fulfill every single order. So I guess my hope was maybe we could, even if we can't provide these things for people, maybe we could make the plans available or make it available so that they could order the parts and put it together themselves. And so that's, I was wondering what the feasibility of that is.
Yeah, I finished up the parts list this afternoon, and that's the complete part list. The boards I had ordered through OSHPark, they're 0.88 inches by 1.5 inches. I think it's $6.60 shipped for 3 boards. The most expensive parts on that entire thing are the 2 SMA edge mount connectors. They're like $5 a piece.
Mm-hmm.
But the whole rest of everything else is all, you know, pocket change stuff, you know, nickel and dime stuff. So I haven't done a total sum, but I have a feeling it comes into something under $20 or $25 for everything. There is one other thing I can do, is that I could panelize the boards such that when you order one board, you get like 50 of them.
Mm-hmm.
If somebody wants to distribute them.
Yeah.
So that's what we got to talk about, but it's doable. I've done that already.
Yeah.
It's a couple
hours.
Is
it something
work.
that TAPR could help out with?
I don't know. That's what we have to talk about.
Okay.
Right now, the board is up on OSHPark. I could make it public and anybody could order it. The parts list is up in the directory with the schematic, the board layout, everything is up on the PSWS documentation GitHub site now.
Would this make a better fit for somebody stepping forward and doing a group buy, or would it be better to maybe to have TAPR buy all the parts and sell a kit?
I'm thinking the former. I don't know what. I mean, the parts are really, you know, 0.1 bypass caps, 10 mic ceramics, and a few other things. So it's nothing special. Either way, it could be done. But I think we need to sit down and talk about it. Just figure out what we need to do. I think it would work either way.
Especially if it's a really inexpensive bunch of parts.
Yeah.
It would really make sense to be able to buy the whole kit, because then you're amortizing shipping over a lot of parts instead of just everybody paying $10, which is twice as much the parts cost.
My new bill of materials has all of the parts coming from Digikey, and the part numbers from Digikey are in there and the quantities are there. So it's one page, boom, you're done.
Because we can certainly buy the parts from TAPR, but we need to get a volunteer to do the kitting.
That's the issue. That's the issue.
But I think that's doable.
The other issue is that people have to put on surface mount components that are very small. I mean, that's it might be a lot easier for people to build the boards and provide the board as a kit. Just saying.
Well, the smallest part on there is an 0805 in terms of R's and C's and L's. There is a SOT23 5-pin regulator on there. There's a standard 8-pin SOIC for the op amp, or so the mixer. The op amp is a 6-pin SC73 or SOT23 6-pin. The smallest part is actually the protection diode. And there's a trick you can play to putting that on, but it is itsy bitsy. So
Smaller
that's
than
what we have to talk about. What's that?
Smaller than a SOT23 or an SOD part?
No, it's insanely small. But there's a trick for putting it on. You put a solder blob on a thing, you slide it in, it grabs the one pin, you solder blob the other side, you're done. So I figured out how to do it, but for somebody who's not well versed in soldering, it could be a problem.
Well, so Nathaniel, what do you think is the take on this? How many are people going to want?
I don't know. I've gotten about a handful of emails so far. And I guess what I'm worried about is that now that we're kind of, whether we like it or not, we're out there. People know about us and people want this thing, even if it just does like a bare minimum. I
also have to provide the image for the Raspberry Pi, which I've now got compressed and ready to go.
Yeah.
So that, that comes up and FL Digi is running with my program, everything's flying. So it's that's ready to go.
That's really the two criteria is you need to build between really below 100. It's not really worthwhile having it manufactured. And
right.
If you're going to build 20, 30, then we'll get a volunteer to cut the tape and mark it. And
I think that's the route. If we could get a volunteer to do, 20, 30, maybe 50, like just enough to kind of appease these people who are like just chomping at the bit to get at something.
But then because build it.
What?
You'll have to build
it. And that's okay, because what we want to tell them is we're like, look, this is a development project. We're working as a community. We're like, this is what's available right now. And because John is, we don't want the world flooded with Grape version 1s.
Right.
We want the world flooded with Grape version 2s and Tangerines.
Well, that was
nor do I want to support the world so flooded with Grape.
Right. But at the same time, I don't want to get this reputation of like, oh, we're just vaporware. We don't have anything, or you can't get anything. Because now Becky wants to run basically a version of Christina's article in QST in August. So like, once it hits QST, people are really going to want this.
Well,
so like
you know that TAPR has a running ad in QEX that probably has some piece of hardware still in it that we don't even make anymore. Nobody's got it to the ad.
Oh, that's not possible. No.
So that would be a good time to update the ad to show this new thing. But once you do that, a QST article, you better be ready for support, because you're going to get 5 or 10 people. You're going to get lots more.
So
that.
Yeah, maybe for the first development, there's somebody here on the list that would like to do this.
Yeah.
I don't see anybody jumping ahead, but they should contact either Scotty or Nathaniel if they have an interest.
Because I'll send it off to our CM and have them built, but you're going to need to build 100. If you're going to build 10 or 20, it's not worth it.
See, I think when the Grape version 2 is ready, that's what I'd like to do. Yeah. But like for right now, I just want a stopgap, even if it is just like, okay, look, Grape version 2 is coming. For now, you want this, go to OSHPark,
make it harder.
Well,
that's harder, right? So
I think that's what you want to do is make it OSHPark with a bomb and a board, and they have to build it themselves.
Yeah.
And
it's not that hard. Those are parts that are not that hard to make if someone knows anything of what they're doing.
And then we're at least appeasing the people who want to be early adopters.
Yeah.
And we're also saying, look, this is a community project. We're not a company trying to like sell lots of these things, for whatever reason. Like we're a research project. And so now you can be part of it. And here's how you do it.
What we need to warn them about is that we have to buy a Raspberry Pi 4 with a case and a fan.
Yes.
You have to buy a Leo Bodnar unit for $140.
Yes.
Or have the equivalent
from us. There's a lot of logistic types of things that, if they see the article, $20, I got this station, then they realize they have to spend another $200 to get everything they need.
Are you using what frequencies are you getting out of the Bodnar unit?
I'm able to do 2.5, 5, 10, and 3.
Oh, so you're creating the.
I have software on the Pi that actually goes out and reprograms the Bodnar directly.
Yeah, but you're doing the local oscillator.
Yes.
Got it.
We're at kilohertz below the beacon frequency, so
right.
I can program 2.499, 4.999, 7.849, or whatever it is, just for WV3 and 7.
So you're relying on the Bodnar for that.
Yeah.
Though
the
of course,
filters are set up for 2.55 and 10 megahertz.
But so I did just notice that there's some problem getting the Silicon Labs part that everybody uses. That's gone in short supply, but you could use one of those units and a more general.
But aren't you going to use the Bodnar GPS for the Mark II?
Nope. John Ackerman's designing the GPS board for us that I'm using.
You're going to use the clock module then for that?
Yes. Yes.
Okay.
I like that approach.
Yeah. I'm just thinking if you're going to use the Bodnar for the Mark II, then you might encourage more people to buy the Bodnar. But now you say, well, that'll be something else. And, you know.
He will not give me the 1 PPS directly, and he will also not give me the timestamp. And he won't give me the GPS coordinates. I mean, it's all, he's spitting it out, and I could reverse engineer it, but I don't want to do that because we're really not going to be relying on it. And what John Ackerman has, he can give me the 1 PPS, he can give me the 4 frequencies I'm looking for, and the 8 kilohertz sample clock.
How close are we to having John Ackerman's unit running?
It's going to follow right on the heels of the data engine. It's schematic is pretty much done. The design for manufacturing info, I have to go through and do that, but I'm spearheading the data engine right now, and it's already so far behind, I'm not going to push it out anymore. But we do have to get the clock module, at least the layout, done before we can proceed on the data engine because it plugs into the data engine. So we have to make sure everything's going to fit.
Yeah, I got to talk to John about that too, because I need direct access to be able to get either the NEMA stream or whatever, so I can make my Raspberry Pi be the Stratum 1 time source.
Talk to me because we have worked out the IOs. So
okay.
they're already done. So let's make sure you're covered.
Okay, we'll talk.
Okay.
I know
John. Yeah. So John, back to like quote unquote kidding this out. What about the possibility of just writing up a single page that I can point people to that say, how do I get one of these? I can go click here and it has the links to the OSH thing, as all the stuff that it's essentially self-supporting. So
I could write that up. It's a couple hours work, but I can do that.
Can't you put a bomb up on Digikey so you can go click and it orders all the parts?
Oh, I've never done that.
There's
can
projects.
Yes, you can.
Okay.
That'd be nice because I'd love to just have a thing that says, okay, yeah, we don't have it made yet, but here, go to this page. Here are all the instructions you need. You can build one yourself.
So what you're saying is you want a fairly high hurdle. You don't want it so easy that anybody and their brother is going to try it, but the people that are serious about it can make that hurdle.
That's right. And that way the people that are serious and really want to do something, they can do something.
And that will identify them to us also.
Yes. Hopefully they'll come and work with us.
Exactly. Yeah. And that's part of what I would tell them. I'd be like, look, you know, this is a community effort for designing these things. And so, you know, part of the amateur radio is this tradition of building things. So now you can go build it. And
hopefully it builds enthusiasm for the Mark II that will come out and be much easier to put together.
Yes.
Yeah. How much is the Bodnar is he asking for his unit nowadays? 200
it's about 140 bucks.
120?
140 in single quantity.
Oh, okay.
You need the dual output one, or can you use the single output one?
You use the single output one.
So you can use the cheaper one then.
Yeah.
That's what I think with shipping, it cost me 145.
That sounds about right.
Okay.
So should we put together kind of like a marketing poop sheet that would describe what we're talking about here so that maybe we could review it amongst ourselves and say, hey, is this something we want to put out there, and use that as kind of a starting point?
It'd be a good review for me. I would appreciate that.
Well, AF80 will volunteer to help you with that, John, because it makes a lot of sense.
If you want help setting up the BOM on Digikey, our buyer here is well-versed at Digikey. You could set that up and then you could just use it.
Okay, I will get a hold of you and talk to you about that because I spent 2 hours this afternoon going through my order lists and populated all the Digikey part numbers.
Mm-hmm.
And it's up on the website now. If you want to go look at the schematics there, the block diagram is there, the full board layout is there, everything. Parts list with, Digikey part numbers. So that's pretty much covered. The OSH link is going to be easy to do because I just have to make it public.
So you can just click on the OSH link and put your credit card in and get 6 boards?
You get 3 boards for $5. Actually, this is 3 boards for $6.60 shipped.
Great.
Yeah. Because it's only 0.88 by 1.25 or something like that. They charge $5 a square inch.
So what would your estimate be of how hard it is to build one, to assemble one of these?
I would say it's above the you know, the very easy, but it's not quite intermediate. Because most of the stuff you're soldering, I specifically chose 0805 parts, so they're not hard to handle.
Mm-hmm.
The only thing that got small was the SOT 23 5-pin and 6-pin. One's a voltage regulator and one's an op amp.
What would be really cool is to commission a student to make a video assembling one of these.
Yeah.
That's an idea.
That's a great idea.
The technique of the little bitty guy soldering the one side down at a time, and then.
Especially since I've got a microscope with a video camera on it.
Ooh.
That'd be really nice. That'd be great.
That's all you need to build one of these. It's a microscope with a camera on it. There you go.
I hear you loud and clear, Bill. That's what the behind me is.
That microscope. I need.
Yeah. We'll have to do some talking about this, but I'll do some logistics and we'll talk about this again.
That sounds really good. I like
it's doable, and it's not. I don't want to dive too deep into it because I don't want to get too far off track. But
no,
at this point, I'm the only one who can drive this, so I have to do it.
Yeah, and I'm just afraid that if we don't do something, like people
are
are
going
gonna
to
keep coming to us, and we're gonna get. So, yeah, I think we have to have some way of handling this.
Yeah, I agree.
Yeah,
if we want to be considered legit.
And
yeah,
you use the magnetometer you use on your board, right? How do you do the magnetometer for the
magnetometer's on Gen 2?
Okay, okay, good.
Yeah. This is just a single channel WWV beacon receiver. It was my concept prototype, and unfortunately, it worked too well.
This is the one you showed off at DCC like 2 years ago, right? Okay.
I have one sitting under my desk here running.
You produce a miracle, John, then miracles are expected.
I know. Been there, done that.
Yeah.
Now, another difficult, prickly question for you, John.
You break it up. I can't hear
you. You can say no, but so the question has arisen, and Jim Farmer has brought this up, that if we send one of these things to Antarctica, there are lots and lots of stations around the world that are on the same frequencies as WWV and WWVH. And one of the ways to disambiguate them is by looking at basically the full spectrum of WWV / or whatever. So I think it's like 8 kilohertz or something like that. 3 kilohertz. Anyway, whatever it is. But I understand that you currently have a 1.6 kilohertz bandpass filter.
Correct.
Is it possible to widen that for the 2 that are going down to Antarctica?
Sure.
Okay.
Definitely doable.
That would be
because I'm limiting it from 160 hertz to 1.6 kilohertz.
Mm-hmm.
That's my bandpass, and I got a couple of them in there.
So it is possible to widen that. So
yeah, just that part value change.
Okay, that might be one good way of mitigating the problem of what you're listening to down there.
Okay.
Okay.
But I'll have to get the receiver back from Christina to modify it. But I've got the other one here, so I can modify this one, make sure it works, and then swap them.
Okay. So that sounds good. And let's communicate.
But I'll need to know what you want for a bandpass.
Yeah, let's have a discussion with Christina and Steve Serwin. Steve Serwin is really one of our experts on knowing what we need to see there. So.
But now that I've got the schematic up, I've actually got the schematic where everything is labeled, all the bandpass filters, all the bandpasses and the frequencies, all in the schematic. So you can look at it and figure out what's going on.
That's awesome.
So it's set up to be, you look at it, you understand it. There's no mysteries about it.
Yeah.
So I'm going to try to make it foolproof.
Where do you have that posted, John?
What's that?
Where do you have that posted?
It's on the PSWS documentation on GitHub.
The TangerineSDR website?
No, not the Tangerine. It's the other one.
It's
HamSCI.
HamSCI one.
Oh, HamSCI.
Mm-hmm.
GitHub.
Maybe I should make sure that is linked from the HamSCI website to.
Maybe I should pop it in there myself. So it's a race who can find it first. I think I'm going to lose.
By the way, while there's a null here, Jonathan, you will be able to set the VCCIO for the clock to whatever you want between 1.8 and 3.3. So since you have your own private clock from the clock module, and each output has its own VCCIO, you'll be able to set that yourself.
So I found the
got it.
link, John.
Oh, okay.
I just have to.
Yeah, that was easy.
Everyone.
HamSCI GitHub went right to it.
Scotty, that's going to be. I would set that in the Verilog then.
No, you're going to supply a voltage output on a pin that will then drive the clock buffer on the clock module directly.
Oh, even better. Okay, perfect. Perfect.
So you could give me permission to share the screen. I can show the schematic real quick.
Go for it.
Oh, sure. By the way, you're showing the Grape Gen 1 receiver.
Oh yeah, receiver.
Receiver? What's
There's a V missing in the
RECEI.
I'm saying on the GitHub.
Oh, okay. But this is the schematic here if everybody can see it. This little guy right here is the itsy bitsy protection diode. It actually can handle a 20 microsecond 1 amp pulse. It's basically a 5 volt back-to-back Zener diode, so it plus or minus 5 volts clamps.
And you couldn't find a bigger package?
Not for the infrared protection that had low capacitance. This only presents, this is the crummy version. It presents 2 puffs. The better version presents a half a puff.
Right.
The connector itself is like 4 or 5 puffs, so that's within the realm of possibilities. But there's your input filter. This is the power supply. This is the mixer section. This is where the Leo Bogar comes in and gets signal attenuated for the correct input for the mixer. And then you just have a simple differential op amp with some gain in the filters. And I got the gain points and the filter points all marked here for the high pass and the low pass filter 3 dB points. And this entire thing off 12 volts pulls 7.2 milliamps. And I'm embarrassed to say, I think 3 of that is running my blue LED.
Oh no!
Gotta have some color.
So
can you make that public on OSHPark, because some of us have all of the components needed to go ahead right away.
Okay. Actually, give me 2 seconds here.
You need some more tabs there, John.
Yeah. How do you keep track of those?
Man after my own heart.
There's a space here someplace to say how many. Oh, here it is. Let it reload. This, by the way, might interest some people. This is an Anderson power pole that plugs into your power strip, and this has got one of those little digital voltmeters on it, so you can measure your voltage on your battery for your field day stuff. And that's a 4 version of it. That's a 7 version of it. No, come on, where are you?
WWV.
There it is there.
Look at that.
That should be easy to build.
See, and that I think that this would be really nice to have, because people are always asking, like I get a lot of people asking, you know, is there something we can build? Is there something we can do? And I'm just
of
like,
course,
as you can see, the price
that
here
has the external uses an external oscillator or internal.
What's that?
Is that external or internal local oscillator?
The LO is the Leo Bodnar. That comes in on this.
Because you realize, of course, that would work even better on, well, it would work fine on CHU.
Oh, yeah. And that's already programmed into my system.
Yeah.
You can do CHU 3.33 and 7.85, as well as 14.67.
Mm-hmm.
depending how strong the signal.
CHU is single sideband with carrier. I always listen to it on sideband.
Oh, okay.
It's quieter than.
That's the whole board.
Just make it public. It would be.
One down. One down. You're on the analog.
Yep, I see that. Blah, blah, blah. I'll have to figure this out, but yeah, I can make it public. Anyway, as you can tell, it's not going to be that much work.
That's really nice.
It's a weekend project.
Yeah.
That was a joke around Open HPSDR. Phil would give us a project and say, I think, weren't the filters a weekend project?
Yeah, the ones that took 2 years.
Yes.
Yeah.
So.
Yeah, I've been on a few of those.
Now, I will point out the reason I was asking about Bodnar and what you're using there. I'm using a series that TI makes of programmable PLLs that, well, in this case, I think you can do an external. I just program standalone, but I generate two frequencies to run the RTL-SDR system that we do. But those are pretty convenient little guys.
Yeah, actually, I had one originally designed into the Gen 2, but when John Ackerman came up with the ability to give me the frequency directly, I took the PLLs out.
Yeah.
So, but that's going to show up in my presentation in 3 weekends from now.
Yeah, this is the CDCE 900 series that I used pretty effectively.
Yeah, I guess John Ackerman was worried about clock jitter or phase jitter or clock, basically how much does it wiggle around when you generate.
Yeah,
right.
Well, as a generic, for the full-blown system, we want to be very cognizant of that. But for this particular application, probably don't need to be that clean.
You're probably right. So anyway,
I have a question for Scotty.
Fire away.
Are you there? With your DE, so in the previous, the HPSDR radios, we did the Ethernet stuff in Verilog.
Right.
So on these boards that you're making, the DE boards, well, the development kit, it has like an Ethernet chip, right?
Has a PHY, yeah.
Yeah. And is that what you have on the DE as well?
Yeah, we have basically a 3-port Ethernet chip, and the port facing the FPGA looks like a PHY.
So is there a reason that we have to do everything in UDP?
Yeah, because otherwise we'd have to do the MAC layer we're going to have to do anyway. We're going to have to put a MAC in the FPGA fabric, and we'll probably use one of the library parts.
Well, for all the signal stuff, UDP is fine, but it would be a lot easier to do the programming with a TCP link.
Yeah, so the problem is that TCP is a lot harder than UDP with our fake ACK on the top of it.
So, I mean, I can do it either way, but I was thinking about this, and I was thinking, well, is that already there? Or
it's not. So that's
okay. There, that tells my question. The other question is, I've been trying to think about this extended packet and how to structure it and variations. So I've got 2 examples of old protocols, and I know we're going to have a new protocol, and we're going to want to be able to swap in descriptors of the different boards and different uses. So it may be a same board, but we might have different FPGA code for special uses.
Right. Well, but the response will be governed by the FPGA program, so it'll look like a different piece of hardware anyway, even if it isn't.
Well, right. But what I'm trying to think about is structuring the packet so that it's able to do it. And what I'm thinking of doing is building basically a structure that has the details of that particular piece, and then we'll just have an ID number in the discovery packet that tells you what part of the structure you're using in this particular radio.
Okay, so when you say, I'm thinking this is going to be part of Discovery, isn't it? Or is this going to be?
Well, yes, in Discovery. Now, Discovery is different than, there should be a Discovery once radio's working, but then there's another Discovery of when there is limited or no other code there. I mean, there will be the bootloader.
If the bootloader's in charge.
Yes, but there will also be should be a Discovery that's a bit different for once the radio's installed.
Okay, because I'm figuring that once the radio is installed, you're still going to be able to request boot mode. Because you're going to have to get into boot mode, which will to invoke the boot. You're going to have to invoke the bootloader in order to reprogram the part.
Yes, right now we use the bootloader for two purposes. And what I'm saying is we might want to separate those two purposes. So have a bootloader Discovery that has the capability of putting firmware into the FPGA. And the other one would be the radio's capability Discovery. And that's dependent on both the hardware and the software of the particular RF board.
So what would happen is when you booted the radio, turned it on, it would boot into the bootloader / Discovery portion of the FPGA. And then when you wanted to operate, say you're good with the program that's loaded in it, then when you hit basically the run bit, then it would program the FPGA, and then you would get the.
Well, we wouldn't reprogram the FPGA, or well, in the way you're thinking about it, yes,
you reload the RAM.
We're reloading the flash.
Reloading the RAM.
RAM, yes.
Yeah, because the flash. So you'd go to the other flash image.
Right.
But the point being is that when you turn the radio on, you always go to the boot image, the known boot image.
The other thing that I'm worried about is the bootloader doesn't need much space. It's small. Right. So we're allocating an awful lot of memory to that.
Well, you can thank Intel for that, not allowing us to share it with memory initialization. So, but the other thing that we can do is we could build ourselves a small bootloader that was part of the radio firmware, and we could copy it into the other side as a bootloader.
It could be on both sides,
It would have to be, because if you munge one side because something happened, you have to be able to get at the other side that's known good, that's never overwritten.
Yes, and the bootloader should be in the same address space on both sides.
But well, but what I'm thinking is you could put the bootloader in the real bootloader that talks UDP. You could put that in local flash memory, external flash memory, external to the FPGA on the board, but not inside the FPGA. And then our bootloader would actually just consist of a small routine to copy that.
Right.
And execute out of it. Because if you're going to, so I'll have to think about this a little bit more, but the thing about it is that yes, the bootloader is small, and yes, you're wasting most of the size of the FPGA, but so what? You're not running the radio, so it doesn't make any difference what you're doing. It does seem like a waste.
Well, when we're running the radio, we want to use as much of that as we can.
Right, but you can still only use the full complement of what gets loaded in the RAM.
Right.
You can never get any more than that. However, depending on how we would structure it, it might be that there would be routine. Well, you can't really do that. I was going to say there'd be routines that would reside in one image that wouldn't be in the other.
Yeah.
But you can't just arbitrarily go back and forth between images. So
well, no, but I was thinking that you'd have a bootloader, and then you'd have a piece of RF code, and you're going to have some clock code somewhere, unless does it have its own? You got rid of the other FPGAs, so whatever it needs to understand.
Whatever the clock module comes up with on its own. We don't have an FPGA there, so.
So you just need to be able to read the pins.
Well, we would talk to the clock module via I2C,
right?
And program it to whatever we wanted. But what you want is stored in the FPGA image.
Okay.
Right, because. But what we can do is, what I'm thinking is that what's going to be in the FPGA image is going to be a NEOS processor.
Right.
And so what I want is code space. I want code space for that processor.
Okay.
And that's why we provided the external RAM. So that we have external RAM and ROM, so we can boot up. We can put the NEOS code, copy it from flash into RAM, and then we can run out of RAM, and we have a huge big RAM. So we'll have enough room for all of the code space, and then we'll have extra RAM for buffering packets and whatever else we need to do.
Okay.
And I guess we'll find out how much RAM we need as we go along.
I'm basically rebuilding what I already know, so that by the time we get to you, we can figure out what's different.
If I could interrupt before everybody disappears.
Yes.
I'm going to share my screen again. It looks like I've got the project shared. I put the link in the chat, and your guys' homework assignment is to see if you can go and try and order the board. And the other thing I wanted to show you is this is a SOT 23 5-pin. This is a SOT 23 5-pin. Those are the two fine pitch parts. This is the 8-pin standard 50,000 spacing chip. This is the diode I'm talking about, that's itsy bitsy. Because see, this is an 0805 resistor. It's smaller than the size of one of the pads. But the trick to soldering this is you put a blob of solder on, you get it hot, you slide the part in so it grabs the one pin, then you just blob the other one, you're done.
So are two of those pins connected together on that diode? Since there's obviously only two pins, is one a no connect?
Yeah, one's a no connect. This one right here is a no connect.
Oh, okay.
Yeah, but it's actually a center tap, isn't it?
No.
It's not connected?
It's just the diode is from pin 1 to pin 2 and pin 3 is unused.
So if I blob the solder from 1 to 3, it won't make it not work then?
Yeah.
Nope. It'll increase the capacitance a little bit, but who cares?
Yeah, a lot of times they make the package polarized like that so that if you have a unipolar part, it can't be installed wrong.
Right. Well, this is a back-to-back Zener, so it really doesn't matter which way you put it in, but it is, that's the smallest part on the board. But anyway, can anybody see the, or try the link? I guess this, Dave Whitten, this is a homework assignment for you. Can you get to my link and order the board?
Dave is well practiced with OSHPark.
Yeah, I've done a few orders there myself. I love it when they upgrade you to the premium service for free, because then you get it in like a week.
Yeah, I just clicked it and it gave me an order option.
Excellent, excellent. So I guess I did share it right then.
Yeah.
I will work on getting a parts list called WWV Radio version 1_11 up on Digikey, and some little blurb right up for Nathaniel to review.
That sounds great, John.
John, I have it ordered already. So
look at that.
Yeah. So
you get 3 boards now, so you get 3 shots at it.
Sure. Well, I'd like to have some backups.
Say, Dave, can I have one of those boards?
if I don't destroy them all.
Yeah. Don, what did you say the link for the Digikey bomb will be?
It right now is up on the PSWS. It's called, oops, let me share the screen again.
There could be a way for you to put that link up as a public link and we can all just click on it.
See, it's under the PSWS documentation. You go under Grape Gen 1. And then the WWV radio is all my Eagle files. And this parts.blm. There's the parts list. quantity, what the part is, the size of the package, what the part designation is, and what the Digikey part number is.
Oh, yeah.
But this is not a Digikey. I mean,
this is GitHub, Scotty.
This is GitHub, so
what I have to do is just put all these in and make whatever that parts list that would be available. So I'll talk to you, Scotty, on how to do that.
Okay.
I've done the hard work. All the part numbers are there. It's just putting them in one place, calling it something that everybody can access.
Yeah. Sounds like a half hour's worth of work. You got all the part numbers.
Yeah.
So
I even included the jumper that you plug on the pins.
Yep.
Which I forgot the first time. Anyway.
That looks great.
Actually, let me go ahead and pop that into the chat. Oh, come on, go back. There. That is the parts bomb in the chat window there.
Not hard to find.
So are there really like, I'm thinking like two levels of bill of materials. One is to build the board, obviously, and the second is to build the system, the Pi, the Bodnar, the board, the this, that.
That's what I got to work on next, because you basically buy a Raspberry Pi 4, the case for it, which has the fan. I also have to provide the image that has the modified FL Digi that comes up and runs and all that stuff. You have to buy the Leo Bodnar. You have to buy some cables to tie the Bodnar to the board, and a SO239 to SMA connector to tie the antenna to my radio receiver. It's all that little logistics stuff. So that's.
And then there's a software to get the right version of FL Digi, though maybe your image contains all that. I don't know.
My image contains everything, and it auto boots, and it's the image that's running in the field now. Also has the personal space weather station setup program, so you can enter in all the space information, your node number, and all that kind of stuff. It's all there. This is the image that I ship now. So,
and it's on an SD card.
Yep. I squished the image down to 12 gig from 32 gig. So it's not going to fit up on GitHub, because GitHub throws up on anything over, I think, 10 gig. We'll have to figure that out too. So there's some logistics we have to work out, but I have to get a parts list of all the cables and the Pi and the SD card and all that kind of stuff. So got more work to do, but I've got the hard stuff, I think, done. I think. Famous last words. 20 hours later.
Yeah, when you first try to build it and you find that, oops.
Yeah, the oops factor.
You know, I think I have an almost identical radio that Ramsey made that uses the 612 or the 602, one of the other.
Yeah, one thing on Jay Silber's presentation he made on the YouTube, he described what we're doing technically a little bit wrong, because he referred to the 1 kilohertz signal that's coming from WWV constantly, which is not correct.
Right.
We're really doing upper.
There's another mistake too. He said that when the sun comes on the ionosphere rises.
Yeah.
No. So anyway, you don't listen too closely to that.
Yeah, there's a couple of things I don't know, maybe on the presentation I'll give a quick theory of operation for the Gen 2 stuff to sort of cover that again, and why we're not using lower sideband for the frequency inversion. So anyway, I'm going to have to get running here, guys. I think I've got everybody's questions covered. If not, please email me. I'm back finally again. So
you haven't made any changes to the pinout, right?
No, the one I emailed you with the Raspberry Pi, that is the one that's in the schematic right now.
Okay, that's the one that I make sure I cover. So we ought to just touch base again once before we cast.
But I need to touch base with you on the pinout for John Ackerman's board to make sure we've got all the pins.
Oh,
he's got to give me 2 serial lines to talk to the GPS unit, which he says he can do.
We already do that. Yeah, I mean, that'll be the baseboard
yeah, because I have to be able to turn my board, the Raspberry Pi, into a Stratum 1 clock reference.
So are you going to take the clock module that we use on the data on the Tangerine and just plug it onto your board? Is that
I suspect that's what we're going to do. Yeah.
Because we have lots of extra I/O on that connector that the data engine doesn't use.
Okay.
Put it on there, hopefully for you and for John's carrier board that he wants to make. So, but now would be a good time to check that because
yeah, that would be a good idea. So yeah, it sounds like I'm coming in at the right time to ask those questions. So
yeah, because actually within the next week or so, we're going to be nailing this down, and then after that, there's not going to be able.
It's not going to be able to change it. Yeah, I get that. So okay, I will be in touch, Scotty.
Okay, sounds good.
Does anybody else have anything else for me? I think I've caused enough trouble for one night, so I will say 7 threes.
73.
73.
Everybody stay healthy.
At least Nathaniel looks warmer now without his coat on.
I'm still in Alaska here with this White Alice radio system behind me.
Turn the transmitter on. That'll warm you right up.
Yeah. You know, at some point I saw this advertisement. It was like an old time advertisement for a GE microwave heater that they advertised. I've been trying to find that advertisement, but I cannot find it anywhere on the internet. But yeah, they marketed this radio heater that you could put in your living room, and you could point it at someone, and it would heat you up.
Warm them up.
Oh, that sounds like a great idea.
I don't know what happened to it. Why did it not?
It probably got sued out of existence.
Yes,
like the X-rays in the shoe stores.
Yeah,
instant cataracts,
cancer, and deformities, and I think it's your heater that's doing this.
Grandma didn't used to have a third eye on her forehead.
Hey, you know, when I was on board the ship, they would tell me about guys who would go out and work on the radars, and they would warm their hands on the radar units that were running while they were working on the ones that weren't operating.
I heard of a guy melting a chocolate bar in his pocket when he accidentally stepped in front of it.
Yeah. These guys were doing it on purpose, though. And I mean, technical guys that should have known better. Not to put your hand in front of the radar. It's like,
oof. Oh, well. On that note, I'll leave you guys alone. Take care. 7 threes.
7-3.
How many people have their vaccines?
I have half.
I got the first one, and I regret it.
Yeah, I got the first one also.
I got one. Getting second in a couple of weeks.
I'll get the second one in spite of what happened after the first one.
Yeah.
Which one did you get, Scotty? Moderna or Pfizer? Or?
Pfizer. And it was, you know, I thought it was a bad reaction, but going online and reading, it turns out it's about a normal reaction, I think. It was 2 days of aches and pains and fever and not feeling good.
You had some immunity already, but
I did.
Yeah, because my wife had both doses of Pfizer and didn't even notice it, you know, at all. And my mother's had both Modernas, thankfully, at 92, and has had no problem whatsoever either there. And
well, it depends on the person. I've had, I'm having a Moderna. My arm was sore, but other than that, that was okay. But I'm told that the second shot can be more of a reaction.
Yeah.
A lot of people have said that, but I didn't have any real reaction to the first or second on Moderna. That's been 3 weeks ago. So
Bill, did they ever tell you whether you got a placebo or not?
Well, I was in the clinical study and back in the fall, and then first week of this year, university contacted me, said, "Hey, we want you to be part of our test group." Okay, right. So I called Moderna and said, "You got to unblind me so I know whether I need this other shot." And said, so they did, and they said, "Okay, you got the placebo during the fall." So I told the university, "Okay, I'll go and do your shots." And they gave me the Moderna too, so I'm still part of both studies since it was both Moderna. So we'll see. But I didn't have a lot of reaction to it. I mean, other than the same soreness you get from a flu shot.
Yeah, I had the sore arm too, but that wasn't the big part of it. Was just the feeling bad for 2 days.
Right.
It
flu
took
symptoms.
it took
a lot
almost
of people
20,
have reported flu symptoms.
It took almost 24 hours for the symptoms to appear, which is interesting.
Interesting.
Yeah, I've heard that. 2 or 3 days. It can be up to a week.
Wow. Okay.
Yep.
Well, my attitude is like my attitude towards getting old. It beats the alternative.
Yes.
By far.
By the way, I found the Ramsey kit that I was talking about. That's the schematic. I don't know if you can see it. It's almost identical.
What's that for?
This is actually a single band receiver kit. What do they call it when you? There's a word for it where you're it's direct conversion receiver.
I think I'm gonna sign off and say 73 for now. I've got to go put together lists of people's emails to send to the iPoster company so they can get people starting making iPosters.
And Nathaniel, I'll send you a synopsis tomorrow. So.
Okay, that sounds really good.
Yeah,
because I'm gonna start building out the I've got to get that schedule up on the website by the end of this week, so that we can start advertising it and people know that what they want to come here.
I gotta sign up too. Nathaniel, I'll maybe talk to you tomorrow.
That sounds, yeah, that'll be fine. I think tomorrow's a good day for.
I'll let you know.
Okay, yeah.
All right, I gotta sign up too.
Okay.
When we sign off, I'm gonna go check the magnetometers.
I'm gonna go QRT also. Good night, all.
Good night, 7.